So in this video, I'm going to walk you through the post lab for Lab 3 Quantum Mechanics. So first thing, you have a data table here. This data table is actually going to be pretty simple. First thing that you're going to do is copy the formula of the compound that you're burning. So you're either going to have the bottle handy, or you might just have there might be just like a little container and it might have a label on it. But whatever the formula is, like maybe the formula is CuCl2. You're just going to copy that down. And then the next thing that you want to do is write down the metal that is present in the metal salt. The metal is the atom that is first in the chemical formula. So if we have CuCl2, the first atom in that formula is copper. That's going to be the metal that's present in the metal salt. Then you'll be reporting the dominant color that you observed. By dominant color, what you're going to find is that some of these, like maybe it's orange, but there's flickers of red or flickers of yellow. Maybe it's green, but there's flickers of blue. So what you're going to be reporting here is just the primary color, the main color that you see when you're looking at the flame. And then you'll want to also report the approximate wavelength of the color that you're observing. You're going to get this from a table, from a data table. So let me just kind of pull up. We're going to be looking at something like the electromagnetic spectrum. And we want to be specifically looking at the visible region. So this is actually a pretty good one that's popping up right here. So let's say that we had an object. Let's say on here we had something that had a dominant color of yellow. Then the approximate wavelength to get that, we're going to look at this spectrum. We're going to look at the visible light rainbow, and we're just going to take a guess at where the yellow is on that spectrum. Like the yellow part in this spectrum is somewhere between 500 and 600. It looks like it's not quite in the center. It's a little bit off-centered. Like maybe I want to say it's like 555. This is you approximating it. It's an approximation. So, I'm not going to say, oh, incorrect. It's actually 560. If you said the dominant color was yellow and the approximate wavelength was 400, I would say that's wrong, because looking at this picture, 400 is clearly violet and not yellow. But just, try to do your best to guess the approximate wavelength of each one of these colors based off of something like a table that you're looking at in your textbook or on the internet. And don't stress about that too much. So there's that data table. And then over here, so you're going to have two unknown metals that you're burning. You're going to report their numbers. They're probably going to be like number 1 and number 2, something pretty simple like that. Again, you'll report the dominant color that you observed, like maybe it is yellow. And then what you're going to do is try to guess which metal is present in this unknown. And you'll do that by looking at your data over here from problem number 1. So you should be able to see, if you had an object that had a dominant color of yellow, what was the metal present for that substance? Like maybe I'll just jam this data together, even though this is really, really, really not accurate because copper is not yellow. But let's say that you had an unknown that you observed to be yellow, and in part 1, you saw when there was a yellow flame, there was also copper metal present. And that's what you're going to be writing down over here. Note that you're only identifying the metal, not the entire formula. So you're only going to be copying the metal. You're not copying the whole entire formula, just the metal itself. And then you might have a couple, it's possible that you might have like 2 different types of metal that gave that yellow color. And if that's the case, you can just write it's one or the other. I don't know. Then in the other part of the lab, you will be looking at the spectra of discharge tube gases with a little spectrometer. There's going to be a list of spectra hung up in the lab that's got all the spectra in it. And so hopefully, you complete this whole thing while you're in lab. You'll be looking at unknown A, looking at the spectrum, matching it up with the reference sheet that's been provided to you in the lab, and then writing down the identity of that gas. This is really something that, if you don't do this in lab, it's probably impossible for you to do from home, but I'm not sure it's possible. And then the last question, question number 4, is saying, it's asking you to give a possible set of quantum numbers that would describe the electron in an excited state. So it's saying in this situation, one of the lines is an electron from 2p jumping up to 3s. So this 3s is the excited state. So this question is just really simply asking you to give a set of quantum numbers that would describe a 3s electron. So by that, it would mean what value of n is possible, and there's only one possible value of n, and what is the value of L, and what is the value of m sub L, and what's a possible value of m sub s for an electron that's in a 3s orbital. So this is like the stuff that we've been practicing in class, filling in these values based on the 3s label. If you're kind of stuck on this, look at your notes, because you do have information in your notes on how to get these quantum numbers from 3s.